Hello students. Today I will explain lesson 5 of standard 8 Maharashtra board. The name of the lesson is Inside the Atom and myself Mrs. Prachi Surdikar will explain you this lesson. Students, if you have not watched the previous videos, please watch the videos for better understanding of general science of standard 8 and also please like, subscribe and press the bell icon. So let us start with our today's topic, that is inside the atom. So you have seen most of the things around you and all these things are made up of matter. So everything which is around you is made up of matter, and this matter is made up of molecules. And now these molecules are again made up of atoms. So matter is made up of molecules and molecules are made up of atoms. So who is the smallest one? Yes, atom is the smallest one. So an atom is the smallest unit of matter. So, if we want to define the atom, the definition will be an atom is the smallest particle of an element which retains its chemical identity in all the physical and chemical changes. So, atom is very small. We cannot observe the atom with our naked eyes. It is indivisible and it do not changes. Whether any chemical reactions or whether any physical changes occur, the atom do not changes its identity, and that is the main character of the atom. So the molecules are formed with the combinations of atoms. Now, in your textbook, on page number 28, this table is given. You have to solve this table. So, students, please note down and understand the answers of this table. So here the first substance mentioned is water. The formula of water is H2O. So here you can see H and O. H is one atom. O is another atom. H means hydrogen. Hydrogen is the first atom. And O is oxygen. Oxygen is the another atom. So here the atoms are combined and hence they are forming the molecule. Hence you will take in is a molecule column. Now if you see H is one atom, oxygen is another atom. So two different atoms are involved over here and hence there are different types of the atoms in a molecule. Now, when two different atoms combined and form a molecule, then it is called as the compound. So, here two different atoms you can see, hydrogen and oxygen, they have combined, and that is why it is the compound. Now, next is oxygen. The formula for oxygen is O2. Now here you can see only O, single atom is involved. The two atoms of oxygen are combining, hence it is a molecule. But in this molecule, only similar type or a single type of the atom is present, and that is oxygen. Can you find any different atom like a water over here? No. So only oxygen is involved and hence it is the single type of atoms in the molecule. And when the molecule is formed by the combination of the single type of the atoms, then it is called as the element, or a single atom is also called as the element. So here only single atom is combined and hence it is the element and it is not a compound. The third one is helium. The formula of helium is He. Here He, can you find He2, He3 like that? No, it means He is itself an atom. It is not a molecule. So He is an atom. Now it is single type of the atom in the molecule and again it is the element. The next one is the ammonia. In ammonia, you can find the formula NH3. It means again there are two atoms, nitrogen atom and hydrogen atom. So it is the molecule in which two different types of the atoms are involved, and when two different types of the atoms are forming a molecule, then they are called as a compound. Hence NH3 is the compound. Then next is nitrogen. The formula is N2. So here it is again the molecule, and similar type or a single type of atoms are involved in this molecule, and as the single type of the atoms are involved, it is an element. The next one is methane, CH4. It's a molecule. Then different types of the atoms are present, carbon and hydrogen. And when two different types of atoms are combined, then they are forming the compound. Hence methane is a compound. Argon. Argon is an atom, it is not a molecule. So it is an atom, single type of the atom, and it is also the element. Neon is also the element. Chlorine, the formula is Cl2. It is a molecule in which single type of the atoms are present, and hence it is the element. So mark down the answers in your textbook. Now we will move towards the different atomic theories. So, as I told you that matter is made up of molecules and molecules are made up of atoms. So these atom is taking part in various chemical combinations. So this concept of atom is more than 2500 years old. Now, scientists, on the basis of various experiments, explain the nature of atoms as well as the internal structure of the atom. And it started with the work of the scientist named as Dalton. So, Dalton was the first scientist who observed, analyzed, and studied the atom, and he put forward some concepts about the atoms, and that is known as the Dalton's atomic theory. Now, what is Dalton's atomic theory? So, according to this theory, matter is made up of atoms. As I told you that matter is made up of atom, and these atoms are indivisible and indestructible. It means the indivisible means we cannot divide that atom further. We cannot make two parts of the atom further. So they are indivisible. And they are indestructible means we cannot destroy that, we cannot vanish that, we cannot finish that atom, and hence it is indestructible. Then all atoms of an element are alike, while different elements have different atoms of different mass. So here he is saying that in an element all atoms are very similar with each other, but in different element the atoms will be different, and their masses will be also different. Then according to the Dalton's atomic theory, the mass is distributed uniformly in an atom. So here that is why you can see that a single sphere is there where uniformly the mass is distributed. That was the postulates given by the Dalton, and it is known as the Dalton's atomic theory. So you all know, you must have seen a bundi laddu. So this bundi laddu is found to have an internal structure. It is formed by sticking smaller particles, that is bundis. So however that solid ball does not have any internal structure. So the atom, as described by Dalton, turns out to be a hard, solid sphere with no internal structure. So, hence, the Dalton said that the mass is distributed uniformly in an atom. Now, next further, The atom is studied by the next scientist called as the Thomson. So his model is called as the Thomson's plum pudding model of an atom. So the plum pudding model of an atom put forth by the J. Thomson. According to this model, the positive charge is distributed throughout the atom and the negatively charged electrons are embedded in it. So, the distributed positive charge is balanced by the negative charge on the electron, and therefore the atoms become electrical neutral. These are the postulates of the Thomson's plum pudding model. Now, why it is plum pudding model? Have you seen watermelon? So, in a watermelon, you can see the red color structure, and on which the seeds are there, which are in a black color. So what Thompson suggests that in a watermelon that fully sprayed red color is nothing but the protons. So protons are distributed everywhere in an atom and electrons are embedded in it. Like that small black color seeds, the electrons are distributed, and hence the positive charge and negative charge nullify each other, and hence the atom is neutral. That was the postulates given by the Thomson, and he compared it with the watermelon. Hence, it is called as the Thomson's plum pudding model of an atom. The next one is Rutherford's nuclear model of an atom. So Rutherford studied the inside of atom by his celebrated scattering experiment and put forth the nuclear model of an atom in the year 1911. Now you can see one diagram over here. So what Rutherford have done? So Rutherford first took a thin gold foil. You can see in the picture a very yellow colored one foil is there. Can have you seen in the picture? So that yellow colored thin foil is made up of gold, and this foil is bombarded with the positively charged alpha particles emitted by the radioactive substance. So in a black cabin you can see the radioactive substance, and which is emitting the alpha particles or alpha radiations. So you can see the labeling also there, that alpha particle emitter. So that alpha radiations were emitted by this radioactive element, and this Rutherford observed the path of alpha particle by means of fluorescent screen around the gold foil. So you must have seen around the gold foil is covered by the fluorescent screen. So the purple color or a blue colored one is the fluorescent screen. So whatever the alpha particles or alpha radiations were emitted, that passed through that gold foil, and then that fluorescence is captured by this fluorescent screen. So it was expected that the alpha particles would get reflected from the gold foil if the positively charged mass were evenly distributed inside the atom. So according to the Dalton, he said that the mass is evenly distributed. So if that theory is true, then the all the alpha particles should deviate back or should get reflect, but it doesn't happen. Unexpectedly, what happens? Most of the alpha particles went straight through the foil, and a small number of alpha particles get deflected from the original path through a small angle. A still smaller number of alpha particles get deflected through a larger angle, and surprisingly, one alpha particle out of 20,000 bounced back in the direction opposite to the original path. You can see that some have passed straight, some have deflected in a smaller angle, some have deflected in a larger angle. So this was the unexpected result from the for the Rutherford scattering experiment. So from this experiment, what he observed or what he concluded is The large number of the alpha particles that went straight through the foil, it indicates that there was not at all any obstacle in their path. There was nothing. It was an empty space, and that is why they went and traveled in a straight line direction. So it meant that there must be an empty space inside the atom in the solid gold foil. Now, the second observation was the smaller number of alpha particles that get deflected through a small or a big angle must have faced an obstacle in their path, and that obstacles are nothing but the positively charged and heavy part causing obstruction would be in the center of the atom. And from this observation, Rutherford put forth his nuclear model of atom. And Rutherford's nuclear model of atom says that there is a positively charged nucleus at the center of an atom. So positive charge is at center. Almost the entire mass of the atom is concentrated in the nucleus. The negatively charged particles called electrons revolve around the nucleus. So around the nucleus these electrons are continuously moving. The total negative charge on all the electrons is equal to the positive charge on the nucleus. As the opposite charges are balanced, the atom is electrically neutral. So there is an empty space between the revolving electron and atomic nucleus. So this is the Rutherford's nuclear model of an atom, which states that the atom at the center there is positive charge. Around that positively charged nucleus, electrons are continuously moving, and the atom is electrically stable as the positive and negative charge get balanced by each other. Now, further, this Rutherford's nuclear model of an atom shows slightly instability in case of the revolving circular orbit, and that is why Bohr's stable orbit atomic model was proposed in 1913. So in the year 1913, Danish scientist Niels Bohr explained the stability of atom by putting forth stable orbit atomic model. So what was the important postulates of this Bohr's atomic model? That were as follows: the electrons revolving around the atomic nucleus lie in the concentric circular orbits at certain distances from the nucleus. So nucleus is at center. If you can compare this with a solar system model. The sun is at center. Similarly, the positively charged nucleus is at center, and around the sun in a circular or the elliptical orbit, all planets are moving. Similarly, the electrons are also moving around that positively charged center, that is nucleus. The energy of an electron is constant while it is in a particular orbit. Whenever any electron is moving in its orbit, its energy is constant. But when an electron jumps from an inner orbit to an outer orbit, it absorbs energy equal to the difference of its energy level, and when it jumps from an outer orbit to an inner orbit, it emits energy equal to the difference of that energy level. So all these electrons are revolving in their circles, in their circular path around the nucleus. But sometimes electrons can jump from its orbit to the next orbit, or from its circle to the next circular path. When it jumps from his orbit to next orbit, it absorbs the energy. And when the electron jumps from its orbit to the orbit which is before to its orbit, then it will release the energy. So he has explained like this. The atom looks like this. You can see the red one, positively charged nucleus, and then such circular paths are there, 1 2 3 4. So in this circular paths the electrons are moving. So first is the K shell. In a K shell, the electron is moving. In the L shell, another electron is moving. Then M shell, another electrons are moving. So when the electron will jump from K shell to the L shell, then it will absorb the energy. And when electron will jump from M shell to the L shell, it will release the energy. So that is the Bohr's stable atomic model. So the next subtopics are atomic structure, distribution of electrons, electronic configuration of elements, and valency. All these subtopics we will cover in our next video. Thank you, students. Thanks for watching. And also, please don't forget to subscribe. Thank you.